Coordinate Geometry, an Introduction. Coordinate geometry. By drawing a grid on a flat surface, it's possible to describe the position of a point with a pair of numbers or coordinates. The idea was developed by a Frenchman, René Descartes. He also showed that lines, circles, and other shapes can be represented with equations. This meant for the first time that geometry problems could be solved by using algebra, or algebra problems could be solved using geometry. On the grid, one of the points is called the origin. Lines are drawn horizontally and vertically from it. These are called the x-axis and the y-axis respectively. Scales are marked on the axes to the right and vertically up. The zero of each scale is at the origin. If the axes continue to the left of the origin or down below the origin, then the scale and coordinates have negative values. If we choose a point on the plane, we can describe its position with two numbers. The first number is the x-coordinate, which is the distance across from the y-axis. In the diagram, the x-coordinate of the point A is 7. The second number is the y-coordinate, which is the distance up from the x-axis. In the diagram, the y-coordinate of A is 6. So we write the coordinates of A as a pair of numbers, 7, 6, in brackets. If the point does not lie exactly on the grid, we can still describe its position. So, for example, the point B has coordinates 3.5, 7.5. And C has coordinates 3 2/3, 2 1/4. Note, although on graphs the scale can be different for the x and y axes, this will cause problems when using coordinates in geometry. Circles will become ellipses and squares will no longer be true. So we must keep the scale the same on both axes. Let's introduce some new ideas. To begin with, gradients. Now a gradient is a measure of how steep a slope is. Gradients are measured in fractions. A very shallow slope will have a small gradient. A very steep slope will have a large gradient. A gradient of 1/3 means that for every 3 meters you travel across, you go up 1 meter, as you can see in the diagram. In graphs and coordinate geometry, we also use gradients. For example, if A and B are the points 1, 1 and 5, 3, find the gradient of the line AB. Now to solve this, we draw a diagram and mark the points AB. We draw a triangle under the line and mark the lengths of the sides. Now the gradient is defined as being the height of the triangle over the base of the triangle. So in this case the gradient is 2/4, which cancels down to 1/2. Now note, if we're going from left to right across the page, if the line goes up, the gradient is positive. If the line goes down, the gradient is negative. We use the letter M to represent the gradient. Now, we have a gradient formula which enables us to find the gradient of a line joining two points without having to draw the diagram. So, if we're given a line passing through 2 points, x1, y1, and x2, y2, we can find its gradient. In a diagram, draw a triangle under AB. Now the length of the base is x2 minus x1, and the height is y2 minus y1. So the gradient is the height over the base, which gives us that the gradient is given by the formula m equals y2 minus y1 over x2 minus x1. Let's look at an example and see how we could use this. A quadrilateral ABCD has vertices A, -1, 4, B, which is 9, 8, C, which is 11, 3, and D, which is 1, -1. Find the gradient of each side. Well, to solve this, we can use the gradient formula y2 minus y1 over x2 minus x1. For AB, we have x1 is -1, y1 is 4, and x2 is 9, y2 is 8. So the gradient of AB is 8 minus 4 over 9 take away -1, which is 4 over 10, or 2 over 5. For BC, we have x1 is equal to 9, y1 is equal to 8, x2 is equal to 11, and y2 is equal to 3. So the gradient of BC is 3 minus 8 over 11 minus 9, which is -5 over 2. For CD, we have x1 is equal to 11, y1 is equal to 3, x2 is equal to 1, and y2 is equal to -1. So the gradient of CD is -1 take away 3 over 1 take away 11, which is -4 over -10, which cancels to 2 over 5. For AD, x1 is equal to -1, y1 is equal to 4, x2 is equal to 1, and y2 is equal to -1. So the gradient of AD is -1 take away 4 over 1 take away -1, which is -5 over 2. Now we notice that the gradient of AB is equal to the gradient of CD. They are both 2 over 5. And the gradient of BC is equal to the gradient of AD. They're both -5 over 2. If we draw the diagram and mark the points A, B, C, and D, and join the sides, we notice that AB and CD are parallel lines. Also, BC and AD are parallel lines. So we can see that parallel lines will have the same gradient. Also, we note in the diagram AB and BC are perpendicular lines. Now the gradient of AB times the gradient of BC is 2 over 5 times -5 over 2, which is equal to -1. So we have the following two results. If two lines have gradients m1 and m2, the lines are parallel if m1 equals m2. The lines are perpendicular if m1 times m2 is equal to -1. The midpoint of a line joining 2 points. Given a line AB with A 1, 2 and B 12, 5, we can see if we draw in the midpoint C, it will have coordinates 6, 4. Now we see 6 is equal to 1 plus 11 over 2, and 4 is equal to 2 plus 6 over 2. So the midpoint C has x and y coordinates that are the means of the coordinates of the ends AB. The x-coordinate of C is the mean of the x-coordinates of A and B. The y-coordinate of C is the mean of the y-coordinates of A and B. So if we're given a line with endpoints x1, y1 and x2, y2, draw a diagram and mark the midpoint. We can see that the midpoint is given by the formula midpoint equals x1 plus x2 over 2 and y1 plus y2 over 2. So, for example, find the midpoint of the line joining the points 2, -13 and -8, 5. To solve this, we use the midpoint formula. The midpoint is equal to x1 plus x2 over 2 y1 plus y2 over 2. So x1 is 2, x2 is minus 8. y1 is minus 13 and y2 is 5. So the midpoint is 2 plus minus 8 over 2 minus 13 plus 5 over 2, which is minus 6 over 2 minus 8 over 2, which is minus 3 minus 4. The distance between 2 points. Let's look at an example. Find the distance between the points A, which is 3 minus 1, and B, which is 6, 3. Well, to solve this, draw a diagram and mark in the 2 points. Now, join AB. Also, draw lines horizontally from A and vertically from B to meet at C. We now have a right-angled triangle ABC with AC equal to 3 and BC equal to 4. So we can use Pythagoras' theorem. AB squared equals AC squared plus BC squared. So AB squared is equal to 3 squared plus 4 squared, which is 9 plus 16, or 25. And so AB is the square root of 25, which is 5. So AB is 5. Now suppose we also have 2 points D with coordinates x1, y1, and E with coordinates x2, y2. If we draw lines horizontally from D and vertically from E to meet at F, we have DF is equal to x2 minus x1, and EF is y2 minus y1. Using Pythagoras' theorem, we have DE squared is DF squared plus EF squared. So DE squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. So DE is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So we have the result: the distance between 2 points x1, y1 and x2, y2 can be found using the formula the distance is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now let's look at an example that uses the distance formula. Find the distance between the points 6, 2 and 1 minus 3. Well, to solve this, we just use the formula. We have x1 is equal to 6, y1 is equal to 2, x2 is equal to 1, and y2 is equal to minus 3. So the distance is given by the square root of 1 minus 6 all squared plus minus 3 take away 2 all squared, which is minus 5 squared plus minus 5 squared, which is the square root of 25 plus 25, or the square root of 50, which comes out to be, as a decimal, about 7.071. Now we could see this from a diagram. If we draw in the triangle, we can see that the base of the triangle is 5 and the height of the triangle is 5. So from Pythagoras' theorem, AB is equal to the square root of 5 squared plus 5 squared, which is the square root of 50, or approximately 7.071. Now below is an example showing the same problem being solved either by using algebra or by using geometry. The problem is this: find the point on the x-axis which is equidistant from 2 minus 5 and minus 2, 9. Well, solving it as an algebra problem, let P be the point on the x-axis and let it have coordinates A, 0. Now the distance from A0 to 2 minus 5 can be found as the square root of A minus 2 all squared plus 0 minus 5 all squared. And the distance from A0 to minus 2, 9 is a take away minus 2 all squared plus 0 take away 9 all squared. Now if we square both sides, this gives us a minus 2 all squared plus 5 squared equals a plus 2 all squared plus 9 squared. If we expand the brackets, we get a squared minus 4a plus 4 plus 25 equals a squared plus 4a plus 4 plus 81. Now we can cancel a squared and 4 on each side, and that leaves us with minus 4a plus 25 equals 4a plus 81. If we subtract 4a from both sides and 25 from both sides, that gives us minus 8a equals 56. And if we divide by minus 8, we get a is 56 over minus 8, so a is equal to minus 7. So the point is minus 7, 0. We can also tackle this problem just by using geometry. So if we draw the 2 points A and B on the graph, we can join them with a line, and then we can construct the perpendicular bisector of the line joining the 2 points. To do this, we place the compass at one end and draw an arc slightly longer than half of the line. Then, using the compass with exactly the same setting, we draw an arc at the other end of the line to intersect the first arc at 2 points. We then draw the perpendicular bisector passing through these 2 points. All points on this line are equidistant from the 2 original points. P is the point of intersection of the bisector with the x-axis. And we see it crosses the x-axis at minus 7, 0. So the point is again minus 7, 0. In this case, one method was entirely done by algebra, and we got the same answer when we did it entirely by geometry construction.